So our learning target for today is I can solve two-step equations using inverse operations. Okay, before we get too heavy into inverse operations, I want to talk about the balanced equation. Okay, so you have to think of an equation like a balance. So let's show what that looks like. So let's say that you have a balance here, like a scale, and you have 6 marbles piled up on each side. So we would consider this balanced. Now, what would happen if I took a marble away from one side? If I took a marble away from this side right here, then all of a sudden your balance is going to tilt up like that. Okay? So if we want to keep this balanced, we would have to take one away from each side, right? And if we took one away from each side, so I'm going to take one away from here, take one away from here, then I would get 5 is equal to 5. So I'm going to cross that out. Cross out one of those, okay? So the equation is still balanced, right? Because I took one away from both sides and now it's still balanced. Now what would happen if I doubled this side right here? Okay, so we double this. There's 5 there, so now we're going to make it 10. 2, 3, 4, 5. Okay, so now there's 10 there. So if I just did that to one side, then whoo, that scale is going to tilt up. So I can't just do it to one side, I have to do it to both sides, otherwise it's not going to be balanced anymore. So 1, 2, 3, 4, 5. Now, what we did is we doubled this side, we doubled this side, and now we have 10 is equal to 10, and our balance is still balanced, okay? Well, this is kind of what's happening with your equations, okay? We need to keep your equation balanced, meaning that if we do an operation to one side, we also have to do it to another. Okay, so let's call this section the balanced equation. So that's the why behind what I'm going to be doing with your equations, okay? So what I'm going to do now is I'm going to do an example, and as I'm doing the example, I'm going to talk you through keeping it balanced, and we'll write some notes in there as well, okay? So we're going to apply this to our equations now. All right, so here's a very basic equation. I'm sure you guys could solve this in your head, but we're not going to solve it in our head. We are going to use inverse operations to keep our equations balanced. Give me just a second. I'm going to check and make sure my daughter made it into her class. All right, she's good. Okay, so what I like to do on my equations so I don't forget to keep my equation balanced is I draw a line down my equal sign. Straight down like that, okay? And then I think of this as like the point on the balance. So what I do to this side of the equation, I have to do to this side also. So both sides have to get everything done to it, basically. Now, we're gonna kind of go backwards for the, remember yesterday when we did the cover-up method, you would cover up this, and then we would figure out what was underneath it. Okay, so if this is what I'm gonna cover up, then this part right here is what I'm gonna undo first. Okay, I'm going to, what I need to do is I need to get rid of this 5. How do you get rid of 5, a positive 5? Yeah, you subtract 5. So I'm gonna subtract 5 from here. Now, if I just take 5 away from one side, then it's gonna be unbalanced. So I also have to take away 5 from the other side. Okay? So now what you're left with, because 5 minus 5 is 0, so this whole thing goes away. So what I'm left with now is just a 2x on that side, and then 13 minus 5 is 8. All right, now I'm gonna look at my variable again, and I see that it's being multiplied by 2. Well, the inverse operation, yeah, Shauna's got it. The inverse of multiplying by 2 is dividing by 2. So I'm gonna do that. I'm gonna divide by 2 here, and I'm gonna divide by 2 here. Well, the reason we do this is 2 divided by 2 is just 1. So you're just left with your x. And then 8 divided by 2 is 4. So now what we're saying is x is equal to 4. So let's talk through this. So what we did here is we subtracted 5 from both sides. Then we divided both sides by 2. Okay. So what hangs up a lot of people here is which operation to do first. You see that you're adding 5 and you're multiplying by 2. Well, which one do I undo first? Okay. It basically goes backwards for the order of operations. So usually you multiply first and then you add. So go backwards. Undo your addition and then undo your multiplication. And if it's easier for you to think about using the cover-up method to help you figure out what to do first as well. Okay? All right, so real quick, I'm just gonna check my answer. So I'm gonna plug in 4 for my x, and I'm just gonna make sure that this is true. So this is 8 plus 5 is equal to 13. 13 is equal to 13, so yes, that, my friends, is the solution. Yeah, it makes sense because you're undoing it. You're basically unraveling it, and so it's going backwards, basically. All right, let's take a look at another problem. Okay. So let's do m divided by 4 minus 6 is equal to negative 22. So just like before, I'm going to put my balance line straight through my equal sign. And that's going to remind me that what I do to this side, I'm also going to do to this side. So if I were using the cover-up method, I would cover this up, which means that the first thing we're going to undo is this right here. So what is the opposite of subtracting 6? Yes, it's adding 6. So I'm going to add 6. And if I do it to this side, I also have to do it to this side to keep my equation balanced. Well, negative 6 plus 6, that's just 0. This has a value of 0. So what you're left with is m divided by 4 is equal to, and then it's negative 22 plus 6 is negative 16. Now what we are only left with one operation, so it's m divided by 4. And what's the inverse of dividing? Multiplying. Great. Okay, so I'm going to multiply both sides of this equation by 4. Okay. Now 4 divided by 4 is just 1. So we've done what we needed to. We got m all by itself, so we can figure out what its value is. And then negative 16 times 4 is going to be a negative 64. Okay. Now, I really want to make sure that I've done this correctly, so I'm going to plug negative 64 in and just make sure that it works. Okay, negative 64 divided by 4 is negative 16. Negative 16 minus 6 is negative 22. So yes, good, it works. It works. That is our solution. So basically, you're always going to add or subtract first, and then you will multiply or divide. All right, so let's get some practice in for you guys. That's a B, not a 6, by the way. Yeah, once you think you know it, you can type the answers, but also don't forget to check your answers too. So some people are getting negative 20 for the first one. Some people are getting positive 20. For the second one, some people are getting 18. Some people are getting negative 6. Do be sure that you're plugging it back in to make sure it actually works. All right, I'm going to start talking through these. I see that my variable's over here. If I use the cover-up method, I'm going to know that I need to take care of that addition or subtraction first. The opposite of adding 24 is to subtract 24. So 24 minus 24 is 0, so this whole thing goes away. And what I'm left with is negative 4p is equal to 80. Now, the last operation that's happening to my variable is it's being multiplied by negative 4. The opposite of multiplying by negative 4 is dividing by negative 4. Negative 4 divided by negative 4 is just 0, so I'm left with p. I'm going to write small here, I'm running out of room. And then 80 divided by 4 is negative 20. Now I don't want to just assume that negative 20 is true. I am going to check my answer because mistakes happen often, which is why it's great that you have the ability to do this, to check your answer. So negative 4 times negative 20 is a positive 80. 80 plus 24 is a 104. 104 is, in fact, equal to 104. So yeah, negative 20 is your solution. All right, let's look at the next one. If I was going to use the cover-up method, I'd be covering this up right here, which means I'm going to deal with this minus 2 first. And the opposite of subtracting 2 is adding 2, so I'm going to add 2 to both sides. So negative 4 plus 2 is negative 2. Negative 2 plus 2 is just 0, so that cancels out. Okay. Now, the opposite of dividing by 3 is to multiply by 3, so that's what I'm going to do. So 3 times negative 2 is negative 6, and then 3 divided by 3 is just 1, so I'm left with b. So it looks like our b is going to be negative 6, but again, I don't want to just assume that because I could have made a mistake. I'm going to plug it back in. Yeah, it works. So I would say your b is negative 6. All right, any questions for me, you guys? How you doing? Yay, nay, thumbs to the side. Okay, now it may be tempting for you to use the cover-up method instead of using inverse operations, but it's very detrimental to your progress in solving equations. So I really need you to make sure that you are solving these equations on your practice using inverse operations, keeping the equation balanced, okay? And just like last night, you're gonna fold your paper in half. You know, Joe, I used to think that the cover-up method was useless, but what I've discovered after teaching this several years in a row is that the cover-up method gives you some intuitive strategies that you wouldn't otherwise have. Because once you've used the cover-up method, it helps you to understand what operation you should be undoing first. All right, so make sure you have your paper folded in half. You're going to have 2 columns, one for solving and one for checking your answer. So solve over here, check over here. I'm going to be looking for several things. I'm going to be looking for your balance line that looks like this. And I'm obviously going to be looking for the inverse operations and to see that you've checked your answers. Okay? So you can go ahead and work on these things, work on your practice until the end of class, and I'll just be here if you need anything. Then you probably need to redo it because you probably did it using the cover-up method. Okay. Yeah, because you need practice using inverse operations. You can go into your Google Drive and take a look at it. Alexa, is that better? Can you see my screen? Okay. We do have some people that are going to be watching this lesson recording, so I'm going to throw up the homework one more time so that they can check their answers. If you're at home, you can pause this at any point or rewind, whatever you need to do. Okay, here, I got it. And actually, Max, your answers are probably exactly the same as they would be, no matter which method you used. So you should just do the inverse operations on a separate sheet of paper. Because all I really need on your homework is